The solar factory's solutions to problems with competing solar panels or solar shingles. We will refer to conventional solar panels or solar shingles simply as CSP. This presentation will answer frequently asked questions regarding conventional solar panel problems. Why the solar factory panels are special. 2x4 studs do not allow the mistake of boards being installed past end of the roof. Doing so will cause great wind loads. Actually, we forbid panels to be placed closer than 16-inch from the roof edge. The 2x4 studs provide a 3-inch high path for air cooling of the panels. Our wiring is obvious because the cables are only long enough to reach the next panel. Any panel can be removed and replaced individually. Our panels are only 23.5-inch wide, but we use extra thick glass, yielding 150 pounds per square foot load capacity. Our largest panels are 24 inches by 60 inches and 160 watts, but only weigh 16 pounds. And finally, our racking system is simply a pair of 2x4 wooden studs. Some conventional solar panels and most solar shingles are nearly impossible to replace interior panels without taking all or most of the panels off and totally reinstalling. Also, most conventional solar shingles are fragile because they are mostly made of glass and should never be used as the primary waterproofing of a roof. If cracked or broken, a roof leak would result. It's very easy to change the solar factory panels. They're strong enough to step on. If the solar factory panels crack or break, no water leak would occur. Some conventional solar panels have intense and complicated wiring that is not obvious. Where would you put a roof-mounted microinverter or optimizer on such systems? The solar factory panels connect like batteries and our cables are only long enough to attach to an adjacent panel, making it extremely obvious on how they should be wired. Solar cell layout on typical conventional solar panels versus the solar factory solar panels. Conventional solar panels have over 36 cells in series, which will result in high voltages and low current. The solar factory panels have 2 or 3 parallel columns of 14 cells, which will result in low voltage and high currents. OSHA limits low voltage to 60 volts, so connecting multiple high voltage solar panels with an output greater than 60 volts will require a certified electrician to install. The next problem is panels or shingles that lie directing on a roof. If air can't flow behind panels, they will overheat and produce less output. How are these lie-flat solar shingles wired? How do these systems deal with a roof protrusion? Where would you install a roof-mounted inverter or power optimizer? And how do you replace a single shingle if one was to break? Would it produce a leak? Why keeping panels elevated and cool matters? Solar panel temperature coefficient is a measure of how much a panel's power output decreases for every degree increase in temperature above the standard test condition of 25 degrees Celsius, which is equivalent to 77 degrees Fahrenheit. It is typically expressed as a negative percentage per degree Celsius, such as minus 0.3% per C degree, which indicates that power output drops as temperature rises. So, if your panels lie flat on the roof, their temperature could reach 185 degrees Fahrenheit on a bright sunny day with calm wind. If they have a typical temperature coefficient, they would lose a quarter of their power output. Therefore, a 400-watt panel would produce less than 299 watts. The solar factory panels creates a tunnel for airflow and inverter placement. Also, our short cables create few obstacles to restrict airflow. The next problem is peel and stick foldable solar panels. What adhesive would be used to attach peel and sticks to a roof? It is extremely doubtful such adhesive hold up to a very strong wind gust. 60 years of history shows adhesive is a major problem with attaching EPDM roofing membrane systems for more than few years, and the same adhesive limit will apply to peel and stick foldable solar panels because air or moisture can become trapped beneath the membrane or solar panel during installation, and especially if the adhesive is applied unevenly or the membrane is laid down too soon after adhesive application. The adhesive will not bond properly under cold or damp conditions or if the surfaces are not properly cleaned. Over time, freeze-thaw cycles and thermal expansion and contraction stress the adhesive bonds and cause delaminations. And finally, foldable solar is notoriously inefficient and expensive. The problem we will discuss is complex racking systems. Racking systems is the mechanical structure that connects a solar panel to your roof. Most require government certification to install because they are very complex, and they allow the solar panel installer to place solar panels in locations that will place tremendous forces on the solar panels and roof structure, if not done properly. Plus, some racking systems place holes in roofs which will void roof warranties. The solar factory panels are secured to the roof via structural screws that go from our upper clamp directly into the underlying roof truss or rafters. This is the entire basis for the solar factory panels. It is that we size our solar panels so that they fit perfectly between roof truss/rafters. The next problem we will address is that some conventional solar panels are too dang big. It's bad enough that these large wattage panels are very bulky and nearly too heavy to pick up. But imagine how much more difficult it would be to handle these large solar panels on a slanted roof and in a strong breeze. A reference source examined the weight of 100 solar panels from competing manufacturers. They found that the average solar panel weight for these top 100 solar panel manufacturers was greater than the 50 pounds OSHA limit one person was allowed to pick up. Again, the 50 pounds limit was assuming no wind load was adding stress. The solar factory produces 4 panel sizes that weigh between 16 pounds for our largest solar panel to only 6 pounds for our smallest. The next problem we wish to present is panels too close to roof edge or even sticking past the roof edge. Panels should never be placed closer than 16 inches to roof edge due to wind lifting loads. Wind uplifting zones. The strongest wind uplifting loads are Zone 3, which are colored green in these diagrams, then Zone 2, which is shown in blue, and the least loads are in Zone 1, which are shown in white. Here are the top 10 solar panel manufacturers. Not one of them makes a solar panel that will fit between the truss/rafters of a typical American roof. Not one of them considered wind loads in Zone 2 or Zone 3. The lowest cost panel was their only goal. Conventional solar panels are weak and fragile because they use thin glass on wide panels. In the example shown here, 2 mm thick glass was used to construct a 44.6-inch wide solar panel. Not only is this a very flimsy design, but 2 mm thick glass will break from the smallest of hail stones. The solar factory panels are the strongest that we can make. We use 4 mm thick glass and an extra strong back sheet on our panels that are nearly half the width of typical panels. The solar factory has designed our solar panels to withstand all wind uplifting loads no matter where it is placed on the roof as long as the roof is north of Miami, Florida. And finally, wider solar panels causes wider gaps. Wider solar panels causes large gaps to be created when roof protrusions must be gone around. This is an example of a solar installer who had no idea what they were doing. We call this ugly roofs.